Today I'm honored to introduce Professor Christoph Freytag from Humboldt University in Berlin. Professor Freytag and I go back quite a ways to our student days when we were both interns at IBM San Jose Research Lab. For those of you who've heard of IBM Almaden Research, that's what it used to be. Professor Freytag has since had a stellar career, recipient of the IBM Faculty Award several times, chaired the VLDB conference.
I even organized one.
Yeah. And more recently, he's been moving into privacy. Looking at privacy issues, is responsible for, I believe, the fastest solution out there for private information retrieval. And going to be talking to us about that. Professor Freytag is actually visiting here in the US right now at Harvard University, which is also where he obtained his PhD from. So I'd like to welcome Professor Freytag.
Thank you, Chris. Thank you everyone for coming. This is an unusual situation for me, so I have to get adjusted that I'm watched from many sides, which I don't even see. I'll try to be as clear as possible, and those who are close to me, please interrupt me if you have questions. I'll try to be as good as possible to answer those on the spot. So what I want to talk about today is certain issues on privacy and databases, and on purpose I put the rest of my title to mobile systems into brackets because I'm not sure if I have the time to enter this part at all, because we might run out of time before we get to that part. So I have the standard structure of my talk. I will try to motivate this work, and I also compare it with some other work that has been done in that area. My term that I will use quite frequently and quite often is the term of so-called access privacy, which should distinguish this kind of work from what I otherwise call data privacy, and I will tell you the distinction in a second. And as I said, we have moved on in this area by participating in a European project called Preciosa, where we try to look at privacy issues in the context of cars, mobile systems, and services that might run from cars in the future, and how to protect those against privacy breaches. So in order to complement what Chris told you about it, this is more or less the summary of what I have done so far in my career. You can see I have not only been at a university, but also at the first 9 years of my life after being a PhD student in industry. So I've worked for IBM on the so-called Starburst project, which is now the DB2 system on Unix. So I was initial on getting the query processing engines going with Guy Lohmann. Then I returned to Europe. I worked for a small company called ECRC doing work in deductive databases. I worked for a company that some of you might remember called Digital Equipment, also long gone. I headed a small research group for them in Europe, and I was paid directly out of the Digital's RDB database system. And in '93, I decided to move into academia because, first of all, the number of places to do research in industry in Europe were dwindling. And second of all, it was a good chance to move into academia because the wall in Europe came down, in Germany came down in 1990. And so the German government restructured a lot of this formerly East German universities, and that opened up many positions. On the other hand, I never lost my contact to industry, so I have been back to IBM as a visiting scientist, and recently I also worked quite a few times with Microsoft. This time I decided academia is the right point, and so I ended up for 3 months at Margot Seltzer's group at Harvard University. So let me give you some introduction to what I'm trying to solve and what my motivation is for talking about what I call access privacy. Consider yourself in a position like this little guy here, trying to access a database, whether or not it will be over the web or directly in a client server setting, whatever the connection there is. And if he or she accesses a so-called patent database, the fact that you are accessing the patent database and the fact what you are accessing there might give an adversary, somebody who watches you, a good idea what you are interested in, and he or she might derive, well, if you are looking for databases and cryptography, this person might have a good idea in this area, and you already revealed something that you might want to hide, because this kind of suggestion might give the adversary some hints that you really don't want to give out. So the real problem is, how can you hide all of that? So let me be a little bit more specific, and I want to zoom in a little bit more clearly. So in a more technical sense, we have a database system or a database server, some kind of client. He or she sends a query, and you give back a result. So I will not, in this talk, talk about the possibility of hiding what's going on when you send the query and sending back the result. That's dealt with or dealt by the communication community. So they have ways to hide things. Encryption is the first step, of course. But what I'm really interested in is what happens if you also allow an adversary to watch what's going on in your database server. So meaning it is not a black box or protected box that does not allow anyone to look inside, but really the adversary is strong enough that he can really see what's going on inside the database system. So a first very naive solution could be a very simple one. If you don't want anybody to see what you are accessing, simply send the whole database, all the data, from the server side to the client side. What's the problem with that solution? Well, I claim it's not scalable. If you have a terabyte database, sending it over the net, it will take some time. That's one reason. The other reason is also, if the server gives up control over the data, he or she might also lose something from a business point of view, because the value of your business might be to have this set of data. I'll only give you a small example. If people in the medical field or other fields, or think even about Google, having these large data sets that might be mined or transformed in other ways, that's where the real value you start. The values is the data, and of course the operations that you apply on those. So giving the data away, I think, is not a good solution for these two main reasons. Maybe there are others as well. So what's left? Before going further, I would like to make again clear what I think is a valid model of how strong or what the abilities by an attacker or adversary is. What do I mean with the term that the attacker, the adversary, can watch the database? And I want to make it clearer here. The attacker is able not to know the content of the record, but the record's position on your storage media, meaning on a disk or a tape or whatever. So we will see that all my solutions will not allow the attacker to look at the content of a record, because it will be encrypted, but the attacker will be able to say this record will sit at this position on my storage media. And this might already be enough to reveal some knowledge about the database, which could be used to find out more about it. Especially, and that's my second term, the adversary himself can also ask queries. So that means if the adversary asks a query, and we will only look at very simple queries, give me record 51, and the adversary can also, when this query is evaluated, can also see record 51 is at position 4711 on disk. Then if another query comes in asking for record 51, the adversary knows it's not only at this position, but also what the content is. And we would like to avoid these kind of attacks or these kind of breaches. So you might say, well, this is an unrealistic adversary model. I believe it is quite realistic, especially when you start to think about today's tendency to outsource your data to third-party providers, let it be on Amazon or anyone else.